Welcome to Summarize Science. Drones are incredible tools for search and rescue, allowing us to cover dangerous terrain quickly. But they often face two major problems. They can be too fragile for harsh environments, and most can't think for themselves, rigidly following a preset path. To solve this, a team of researchers designed and built a completely custom drone specifically for rescue missions. They built the frame with lightweight but strong carbon fiber, and for the parts that take the most abuse, like the landing gear, they used a special flexible 3D printed material. This material has a unique internal pattern that makes it excellent at absorbing shock from hard landings. Simulations showed it could even withstand a drop from 15 meters high. But a tough drone is only useful if it's also smart. This drone's brain is a combination of a Pixhawk flight controller, which handles the flying, and a Raspberry Pi 5, a powerful mini-computer that runs the artificial intelligence. Using an onboard camera, the Raspberry Pi constantly scans the ground, running an efficient AI model called YLOV8N to spot potential targets in real time. This is where the drone's clever strategy comes into play. It starts by flying in a systematic sweep pattern, much like mowing a lawn, to ensure it covers the entire search area. But the moment its AI camera detects something, it instantly switches modes. It abandons the grid pattern and enters service mode, immediately flying to investigate the nearest detected points of interest. After it has checked on the new targets, it doesn't just stop or return to base, it seamlessly returns to the grid and continues the search right where it left off. If it detects more targets while servicing the first ones, it adds them to its queue, constantly reevaluating the most efficient path. This dynamic ability to replan its route is crucial in a chaotic rescue scenario. The researchers tested their custom algorithm against other methods. A simple nearest neighbor approach is very fast to calculate, but results in a very long, inefficient flight path. On the other hand, a globally optimal algorithm finds the absolute shortest path, but takes far too long to compute for a real-time situation. Their proposed algorithm, called LG, hits the perfect sweet spot. It makes a decision in just 4 milliseconds, but creates a flight path that is nearly as short and efficient as the perfect one. So let's recap what this all means. The researchers have developed a blueprint for a search and rescue drone that is low-cost, exceptionally durable, and highly intelligent. It's tough enough to survive the demands of a disaster zone and smart enough to adapt its mission on the fly without human intervention. This work is significant because it makes advanced autonomous capabilities more accessible, using off-the-shelf components and free software. In the future, this could lead to teams of these drones working together, autonomously coordinating to search large areas and helping to save lives faster than ever before.